Okay, we're going to look at square roots in a kind of a deeper way than you've seen before. You know what a square root is. Like the square root of 25 is the number that multiplies by itself to equal 25. But what does it really mean? Actually, square roots, the point of it it was all about area. Squares and square roots were done when they were working out land thousands of years ago. And let's just look at this idea of square roots and fractions. Now, this Canadian textbook starts off here, and they say each square below has been divided into 100 parts. Okay, so it's 10 by 10. There's 100 squares here. 10 times 10, if you counted them all up, there'd be 100. You can't see it very well, but everything is shaded except for the top row and the right column. All of this is shaded. Well, the question they ask, for the shaded area on the left, what is the area? Well, it's 9 squares this way, 9 squares this way. We don't have to count all the squares. We know it's 9 times 9. So 9 times 9 makes an area of 81. How can you use a square root to relate the side length to the area? Well, the big idea is if you take the square root of the area 81, if you've got a square, the side is the square root. So that's 9 by 9. So the square root of 81 is 9 because 9 times 9 is 81. What if we looked at one of these squares and we blew it up? We made a big thing here that if this was 1 unit here, then this looks like it's broken into 10 parts. Each one of these is 1/10 of a unit, 1/10 of a unit. So what would its area be? Well, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths because each one's a tenth. So it would be 9 tenths. To figure out the area, we'd go 9 over 10 times 9 over 10. You multiply straight across. This area here must be 81 over 100 square units. Well, if you knew the area was 81 over 100, you could get the length of this square by taking the square root of 81 over 100. That's the big idea. The square root of 81 is 9. The square root of 100 is 100. Let's look at it in some examples here. Say we knew if this was 1/10 of a unit here, each side of here, say there were 15 of these. Well, the area of this thing would be 15 over 10 times 15 over 10. 15 times 15 is 225. 10 times 10 is 100. So that would give you 225 divided by 100. It'd actually be 2.25 square units. That would be the answer. What if you knew the area was 169 over 100 square units? Gee, that's 1.69 units, if we changed it to a decimal. But if we knew what this is the area, how would we figure out the length of one of the sides? Well, we'd take the square root. And because 13 times 13 is 169 and 10 times 10 is 100, the square root of 169 over 100 is 13 over 10. So the side length is 13 over 10 units. Now we're going to do a whole lot of questions on this idea of taking the square root and the idea of having a fractional answers for the side. But before we do, let's just look at one more example here. Calculate the number whose square root is 3 over 8. So we're looking for a number. When you take the square root, it is 3 over 8. Well, all you've got to do is, if this is broken up into 8s, there'd be 8 little squares this way, 1/8. Each one would be 1/8. And 1/8 times 1/8, that would make, there'd be 64 little squares here. So this would be 1/64 of a square. Well, here's 3 out of 8 right here, that length right there. This is 3 out of 8 here. See, it's 8 all the way down, 8 little 8th units here. If we go 3 over 8 times 3 over 8, we get 9 over 64. So 3 over 8 is the square root of 9 over 64. Well, what if you knew that this was 1.8 units? What would the area of this be? Well, you'd just go 1.8 times 1.8. That's 3.24. That's what it equals. So the square root of 3.24 is 1.8 units. Okay. Well, those are all the examples, and then we are going to do a whole bunch of questions. When it says check, it should be kind of basic and not too hard, although they're not also very easy. And then when it says apply, it makes you think a little bit harder, and there's quite a few questions to work on. So there they all are. Good luck with it all.